If you're having trouble with growth and decay, you might want to check out page 337 in the textbook. It has some great tips and guidelines. Okay, let's move on to example number 2, modeling population growth. In a research experiment, a population of fruit flies is increasing in accordance with the exponential growth model. After 2 days, there are 100 flies, and after 4 days, there are 300 flies. How many flies will there be after 5 days? So our exponential growth model is y equals c times e raised to the kt power. We are given, after 2 days, there are 100 flies. After 4 days, so that's both time, 2 days, 4 days, that's both time. There are 100 flies, and then after 4 days, there's 300 flies. So there's our growth. We go from 100 to 300. How many flies will there be after 5 days? And that's the ultimate question. How many flies are there going to be after 5 days? Well, this increases by the exponential growth model. So you can't just simply figure out linearly what's happening, because the increase from 300 or from 4 days to 5 days isn't the same as the increase from 2 days to 3 days. Let me show you. We've got an end amount of 300 and we've got an initial amount of 100 times E. We don't know what that growth constant is, that constant of proportionality. Don't know what it is, so we're going to leave that as K, but we do know that going from 100 to 300 flies, that was over the course of 2 days, from 2 days to 4 days. Now we can divide both sides by 100 and isolate that exponential expression, e raised to the 2k power. So we're going to have 300 divided by 100 is 3, equals e to the 2k power. Now I'm going to put this in log form. Log base e, which is the natural log, of 3 is equal to 2k. Divide both sides by 2, and we're going to have k equals the natural log of 3 over 2. The natural log of 3 is just some number. It's 1 point something divided by 2. I'm going to keep that as an exact form, and I'm going to put it into our formula, putting 100 as still the initial amount, because that's not ever going to change for this problem. That's the initial amount that we know of, times e raised to the k, which is natural log of 3 over 2, times t, which would be how many days? After 5 days. So from 2 days to 5 days, that's 3. I put that into my calculator, and I get an end amount of fruit flies being approximately, let's see, approximately, drum roll, 520 flies. 520 flies. So hopefully, if you didn't get that yet, go ahead and press pause. Make sure that you can get 520 flies. We want to make sure that you know how to put this into your calculator. That would be 520 flies after 5 days. Now you might be asking, why didn't we put a 5 in for time? Well, that's because our initial amount of time started with 2 days. So 5 days from 2 days, right? So our initial amount was 100. So we have to start with time being 2. 2 to 5 would be a difference of 3. Most awesome. Excellent. Find the exponential growth if a population of fruit flies is 100 after 2 days and 400 after 4 days. Go ahead and give this a try. And when you come back, I'm going to give you an answer. Find the exponential. I think I need to add to the question. Find the exponential growth if a population of flies is 100 to 400 after 4 days. We want to find after 5 days again. So we want to find after 5 days. I got that my population of fruit flies would be approximately 800 fruit flies after 5 days.